Either you think that man-made climate change poses a terrifying existential threat to humanity. Alternatively, you may believe that we still have enough time to simply solve the problem of global warming. Whatever the case may be, let us all agree that humanity is spewing much too much carbon into the atmosphere. Welcome to the Future Tech Lab, and today we are going to tell you about how carbon capture technology can save the world. A huge new facility has opened on a desolate plateau in southwest Iceland, surrounded by dark crags and patches of green moss, with the bold promise of helping to counteract climate change by absorbing carbon dioxide from the atmosphere. It is the world's largest such complex, with boxes the size of shipping containers capturing 4,000 tons of greenhouse gas every year, according to its operators. This will then be pumped deep down, where it will miraculously change into harmless rock. Scientists are pushing this cutting-edge but pricey technology as a major answer to the climate catastrophe as global leaders gather in Glasgow for COP26, the United Nations climate meeting. Others argue that its high price and voracious hunger for energy are impediments to global emissions reduction. Its harshest opponents call it a foolish and untested strategy that serves as a cover for the worst polluters. However, with plans underway for even larger direct air capture operations than the one in Iceland, proponents think this groundbreaking technology will help mankind achieve carbon neutrality and limit global warming to 1.5 degrees Celsius, as agreed upon worldwide, 2.7 degrees Fahrenheit. Professor Stuart Hasseldine, a specialist in CO2 storage and climate engineering at the University of Edinburgh, said, "Direct air capture is absolutely important for attaining net zero. To extricate ourselves out of this situation that technology has created, we need technological answers. I'm all for planting trees and rewilding, but neither is sufficient in and of itself. Part of the solution is direct air capture, as well as utilizing far less fossil fuel." The carbon capture facility in Iceland, which debuted in September and utilizes human-sized fans to suck air into its ducts, is located a half-hour drive outside of Iceland's capital, Reykjavik. CO2 builds up on a thick filter before being released by 100 Celsius, 212 Fahrenheit, bursts of heat from the island's volcanic underbelly's sustainable geothermal energy. The gas is then dissolved in water and piped underground via pores and fissures in basalt rock up to 2,000 meters, 6,600 feet deep. It cools, interacts with minerals, and transforms from a climate-warming gas to a risk-free rock in 2 years. The industrial plant, dubbed Orca after the Icelandic word for energy, was built by Climeworks, a Swiss carbon capture firm, and Carpix, an Icelandic company that specializes in converting CO2 into stone. This technology does not provide us with an excuse to continue doing business as usual, Sandra S.M. Bjornstadtir, a geologist in charge of CO2 storage in Iceland, stated. "First and foremost, we must not emit CO2. We must decarbonize. Rising CO2 levels in the atmosphere are driving global temperatures to rise, as well as an increase in droughts, floods, and other extreme weather events, all while wreaking havoc on the planet's ecosystems. On the other hand, merely reducing greenhouse gas emissions isn't enough. Significant and long-term capture is also critical, especially because a recent UN report indicated that countries aim to extract more than twice the amount of fossil fuels required to maintain global temperatures within safe limits." In a major 2018 study, the Intergovernmental Panel on Climate Change stated, "There is no historical precedence for the scope of the necessary transformations. Techniques to take CO2 out of the atmosphere might theoretically contribute to keeping warming below 1.5 degrees Celsius. The Icelandic complex is simply one of various technologies for removing CO2 from the atmosphere. All of them are at various states of preparation. Some require preliminary laboratory investigation, while others are nearing large-scale adoption. Planting trees, the original carbon capture hubs, is one method that is more recognizable. They absorb CO2 from the atmosphere while also improving wildlife habitats, which is crucial for preserving biodiversity and preventing flooding. However, trees take time to mature, and when attempting to store carbon eternally, they are prone to logging, land removal, and wildfires fueled by a changing climate. Scientists are also concerned about the massive amount of land and water required for this tree planting strategy. Nature-based solutions, according to experts, are vital but insufficient in and of themselves. Nevertheless, the present size of CO2 emissions dwarfs our man-made methods for reducing them. Despite the fact that human activities produce tens of billions of tons of CO2 into the atmosphere each year, the new Icelandic plant can only catch 4,000 tons of this planet-warming gas. Experts advocate for a large-scale deployment of these systems with far higher CO2 capture capacity. You're going to need 10,000 of them throughout the world, Hasseldine said. That seems like a large number, but it's the same as the total number of large power plants in the globe. So it's the kind of stuff that's previously been done. These are on the horizon already. You're going to need 10,000 of them throughout the world, Hasseldine said. That seems like a large number, but it's the same as the total number of large power plants in the globe. So it's the kind of stuff that's previously been done. These are on the horizon already. Carbon Engineering, a Canadian business, has chosen Scotland and Texas for two massive complexes, each of which will be able to remove up to 1 million tons of CO2 per year, the equivalent of 40 million trees. These facilities will show that large-scale direct air capture technology is a practical, inexpensive, and available instrument that is ready to assist drive global emissions down to net zero, and eventually net negative, said Steve Oldham, Carbon Engineering's head. Carbon capture technology, according to Georgi Gallos, a climate campaigner for Greenpeace International, is at best stupid and at worst dangerously cynical, as it is expensive, underdeveloped, and untested to function at scale. It's a smokescreen to hide the fact that emissions are still rising, he remarked. The true solution is immediate emission reduction, which includes, among other things, halting new fossil fuel projects. Carbon capture technology has a number of drawbacks, not the least of which is the cost. The bill for removing billions of tons of carbon dioxide would be staggering, costing upwards of $600 per ton. However, as technology develops and grows, prices are projected to fall, much like the price of once expensive solar panels. Within 20 years, experts expect that the cost will fall below $200 per ton. Meanwhile, expenses can be offset by selling CO2 to agricultural, beverage, or energy firms for use in growing food, adding fizz to beverages, or combining with hydrogen to produce fuel. Another difficulty is that CO2 only makes up around 0.04% of the air. Therefore, extracting it from massive quantities of air needs a lot of energy. Power sources that are both green and dependable are essential. Iceland was an obvious candidate due to its high concentration of volcanoes, as well as its inexpensive and plentiful supply of geothermal energy and the correct sort of rocks for CO2 mineral storage. These circumstances paved the way for more air capture centers in places like Hawaii, the East African Rift, sections of Russia, and Southeast Asian countries. However, the process requires a large amount of water, as well as the availability of porous basalt rock, which is plentiful along continental borders but limited elsewhere. The time is running out, and some environmentalists remain skeptical of the technology. Friends of the Earth criticized direct air capture as futuristic, untested, and hazardous in a study this year, saying the approach is unlikely to ever operate at scale, and that investing in it may even lead to increased fossil fuel extraction. However, the road out of the climate issue looks to be different from the lava fields of Iceland, where air is sieved of CO2 in an unprecedented attempt to chill the world. There we have it, which brings us to the end of today's video. So what do you think about carbon capture technology? Please leave your answers in the comments section below. Do not forget to subscribe to our channel. While you're at it, hit the bell so you never miss any of our videos, as more exciting ones like this are on the way. In the next one, I'll see you.